easy today. So let's look at problems 1 through 4. Are there any questions on problems 1 through 4?
No. You should just go over. Yes.
So we can understand how.
So now, one way that I figured we could do the first ones, I mean, if we know for, say, number 1, that this is going to be parentheses negative 256, comma 100, bracket, because parentheses if it's included, brackets if it's not, and we have 2 endpoints. This is one way we can look at it. Now, the other way is, because I have a feeling most of y'all are comfortable with graphing this on a number line, yes? So, negative 256, would it be included? Why not? Right, it's not, what? It's not equal to, yes? So at 256 it would be open, at 100 it would be closed, because it is equal to. Right, and then we would shade in the middle, yes? Now, it might be easier, because most of y'all are comfortable with graphing it. Now, going from the graph to the interval. So the smallest number we have is what? 256. Is it included? Is it filled in? No, so this would be a, then our other number is, and is it included? So it would be a bracket. And that's it. Yeah, I don't know why I haven't done that sooner, but it's easier to go from the inequality to the graph, and then we can write the interval. But the only thing I'm looking for is the interval.
So if the x is on the
Mm-hmm.
So it's the one with like the
Yeah, so here, we only have one number, yes? Is it included?
No.
So would it be shaded in? Okay, so it's going to be open. Now, which way do we shade? Because x is what? So we would shade to the left, to the less than side. Now, the direction the arrow points only works if x is on the left. If x is on the right, it does not point that way. Now, whenever we have it going in one direction, where it's only going straight off and it includes one of the arrows, we will include infinity or negative infinity. Which way is this one going? Is it going to positive infinity or negative? Negative infinity. So the smallest number this time is negative infinity. And anytime we have an infinity, it has to have a parenthesis, not a bracket. It will never have a bracket. And the bigger number is, will it have a parenthesis or bracket? Parenthesis. And that's it.
So how'd you get negative infinity?
Because where's the graph going? Towards the negative infinity. Because if it we shade and include the arrow, we're going to have one or the other. Mm-hmm. Now, if you don't need the graph, you understand how to do this without the graph, then you can do it without the graph. So I'd only put the graph if you find it helpful. Okay?
Wait, so where do we put the brackets?
Brackets equal to it.
Yes. Brackets when it's equal, parentheses when it's not. Because brackets saying it's included, parentheses is saying it's not included. Do any other questions on 1 through 4? Questions on 5 through 8? So if we looked at a graph, our main number that we have is 9. Is it included? Now, do we shade to the right or to the left? Which number is bigger?
Oh, no. Yeah.
All right. So we shaded to the left because 9 is greater than x, yes? Now, we don't shade towards where the arrow is pointing because x is not on the left, it is on the right. Now here, okay, this one included an arrow, yes? We shaded into an arrow, so we're going to have to include infinity or negative infinity. Which one would we have? Negative infinity, because it's going in the negative direction.
How do you draw it? It's not. It's set with 8.
Sideways 8.
I always have to trip my paper.
Yeah, you can do that too. I just kind of go over and around. Yeah, it's pretty much figure 8. Any other questions on these here? Questions on 20 or 9 through 14? 10. All of these here are going to start the exact same way. Print or brace X bar. Now what this is saying is the set of all real numbers X. Now we could change it a little bit to depending on what we have, but most all of them will start with this here. Then we describe it. So what do we have? The set of all integers. Well, brace X bar is the set of all real numbers, yes? Okay, we have to define this. So X is a what? An integer. And then we finish off with what? Greater than or equal to 200, because that's also what it said. Now, if it had said X is a real number or just gave us the inequality, we don't have to include that X is an integer because it's not specifying that. Yes. Now, we could have just said X bar, X is an element of the integers and X is greater than or equal to 200. This works too. Both of these are the correct answer. You just need to pick one of them to use. Questions on this here? So we want to look at which one? The set of all natural numbers greater than 56. So again, we'll start the exact same way. Brace X bar. X is a natural number. And, well, I ran out of room. X is, we'd write that as one line. Well, what's the symbol for natural numbers? Yeah. So that's what we would have. Nope. I still have the eraser selected. We can say X is an element of the integers and X is greater than 56. X is not equal to -2. Yep. Because it says it's a real number. Now, we could have said X is an element of the natural numbers such that X is greater than 56. That's the same thing. Because instead of saying, well, X for all real numbers X such that this is true, we already said it. We don't have to say it in the description. We just changed the set that we're looking at. Any other questions on this here? With inequalities or these interval notations, you just need to revert them back to an inequality and then stick them in. Any other questions on these here? Yeah. So how would we rewrite the interval 6 to infinity as an inequality? It'd be what? X is greater than 6. So then we would say the set of all real numbers X such that X is, yeah, that's it. As if we're talking about an interval, it is automatically all real numbers. $14 would be the same thing. It'd just be the set of all real numbers X such that X is less than or equal to -4 or X is greater than 4. Because we're just changing those into inequalities. Any other questions on any of this here? We ready for the next ones? Yes? Questions on 14 or 15 or 16? Yes, do we want to do it at the calculator? Because on the test, there's only one that you have to do the hand, and that's the bonus. The rest of them you can do in the calculator. So 16, if we're doing this in the calculator, we need to make sure it's in the form of x, followed by y, followed by z, all on one side, and then the constant terms or the numbers are all by themselves on the other. This is true for this one here. So then we can pull up the calculator, and we can go second matrix and over to edit to put the matrix in. Now we input the matrices. We want to put them, because we're looking at 16, right? Whenever we have a 3-variable system of equation, it's always going to be a 3 by 4. That's just how it is. Now we just put the coefficients in. So -4, 1. And I have a feeling at this point you're getting faster and faster at plugging these in, especially with enter. Using enter after each number makes it even faster to just run through them. Now at this point here, we can go second quit. Second matrix. Yes, we'll look for RREF. Now make sure that you hit RREF and not REF. REF is row epsilon form. It tries to get those ones, the diagonal of ones that we normally get, but it does not reduce everything else to 0 on that side. So we have RREF, second matrix, and we pull up A and hit enter to where we have that first kind of 3 by 3. It has the diagonal of ones and everything else is 0. That's what we want to let us know what the value of X, Y, and Z are. Now I will go on and show you this here, as if we picked REF, second matrix, A, enter, we get this here. But if you notice, these spots here, which are 0 and the other one are not 0, we would have to do some more to it to figure out what the actual answer is. So our REF, reduced row epsilon form, where it reduces our 1.25, 0.25, and our 1/3 here to 0, actually gives us the final answer. So -4, 0, -2. So -4, 0, -2. This here is the final answer. Question? Well, we put X, Y, Z. That's how, because again, we made sure X was first, Y was second, Z is third, so it's going to come in the form X, Y, Z. Does that make sense? I will mark it wrong if you, instead of putting this here, put 0, -4, -2. I will mark those wrong if they're in the wrong order. Yeah, as long as you put the equations in the form of X, Y, Z, it's going to go X first, Y in the middle, Z last. It will list them out that way. Okay? Questions on this here? We need to see another example of one of these. Because whenever we do ordered pairs are always in parentheses. Yep. Any questions on this here? If we have time, we can come back and do one of these. I will show you how to do one of these by hand. But I think most of y'all feel pretty comfortable with doing it by hand at this point, yes? It just takes time. State the dimensions and write the augmented matrix. So whenever we write the augmented matrix, we need it in the form of X, Y, Z. We need it ordered. And then putting the numbers in. 19 through, what is this? Is there any one of those that y'all want to look at on 19 through 24? 20? Yep. Okay, we just have to rewrite the second one. Now, we could do that. Now, if you see how it works and you can switch it in your head, that's fine. But what we could do is just switch it since they're both on the same correct side and get this here. Because all I did was switch those two. Now, normally when I do this, especially when I was in high school, I would mark out the original equation. Because that's not the one we're looking at anymore. We're looking at the one where the X and Y are switched. And I would do this so that when I go to write or use the equation, again, I'm not looking at the original one, I'm looking at the one we actually want. Now going across the top for the first equation, we have 6 for x and then 0 for y, 4 for z, and 2. Our next equation would be negative 7, 1, 4, 15. 3 by 4. And we only have to include a 0 for the variable if the other two have it. Or not even the other two, if one of the other two have it. Or if one of them has it. If one of them has x, y, z, the others have to have a value for x, y, and z. There's no z in either one on 19, so I don't have to put a 0 for z on either one. If you do include zeros for z on either one, I will count off points for that because it's not needed and it's changing it a little bit. Questions on this here? Now I will tell you these are some of the most or the highest point problems on it because I'm counting a half a point per element in that matrix. So each one of those that you get wrong is a half a point. Yep, so 6 and 0, if you had those flips, that's a point. Because a half a point for 0 being in the wrong spot, half a point for 6 being in the wrong spot. So each one of those is half a point. But because if you get this right, that's 1, 2, 3, 4, 5, 6, 7, 8 points for this one problem. And again, I did that on purpose because I'm having this offset some of the other stuff. Yeah, I know those are frustrating. Okay. Any other questions on these here? Any other questions with writing the augmented matrix in dimensions? And you'll need to remember both. If we feel good with these here. Questions on 25, well, let's look at 26 out of all these. Now, for the test, I'm going to be nice and only make y'all do up, down, left, or right, or one or both. Now, if we're going up or down, we're going to stick with the general form of f of x plus k. If we're going left or right, it's f of x minus h. We're going to pick one of these two depending on the movement that we're using. So again, you're not going to have to worry about vertical stretch or shrink, horizontal stretch or shrink, or reflection across the x or y axis. We're not going to deal with any of those. Or we can do this one here. So now whenever we have more than one, because there's going to be at least one that does have more than one, we do it as we read it. We use each operation or apply each transformation as it is presented. All right? Now, let's look at this first one here. So what is the first transformation that it says? Right 4. So left and right is our f of x minus h. So we'll have x minus, and we're going to put whatever value in for h that we're applying. So it's going to be what? 4. The f of x is the absolute value of 2x minus 1. So our first translation is right 4. Yep. So we're putting in h. Now it is positive 4 because we're moving to the right. So the number we replace h with is positive 4, or just 4. If it had been left, we're going to replace h with negative 4. And the negative and negative then would make it positive. So now we could call this g of x so that we can tell the difference on the next part. Because again, we don't have one transformation, we have two. So our next movement of up 3 is not going to affect our absolute value of 2x minus 1. It's going to affect the one that we actually translated to the right 4. So after we finish translating it right 4, then we're going to take that new one and move it up 3. Now, here, I've taken and replaced x with x minus 4, yes? So over here in the function, I'm going to replace x with, and get the absolute value of 2 times x minus 4 minus 1. So we're just replacing that x with x minus 4. Yes. Now after we do that, we will need to distribute the 2. Absolute value of 2 times x is 2x. 2 times negative 4 is negative 8 minus 1. Combine like terms and we get 2x minus 9. Questions on this here? Now we need to do what? Up 3. Now we can use g of x plus k. And again, I use g of x for this one so that we can kind of help ourselves distinguish between the two. I don't think it said in the directions of what our final function should be. I think it might have said g of x, right? The function g of x. I am not counting off points because you didn't finish with g of x. I'm looking for the function. Again, g of x is just a way to name it. Now, what's our value of k? Up 3, so it's going to be plus 3, yes? Minus 9 plus 3. Do I need to add the parentheses for this one? No, because there's not a number in front of the parentheses. I'm not having to multiply through anything. It's just going to be what it is.
What was that?
Yeah. So, that there's the answer. You don't have to do f of x, g of x. I'm just looking for the function.
But so could we use, say we use g of x plus k for both of them, would it matter?
No. I used a different one that way, especially if you're looking back at it, you can see the difference. And not f of x plus 3, and we put 2x minus 9, and you're trying to figure out why did I use that instead of the 2x minus 1. It's just a way for us to distinguish between the two. As long as you can keep it straight, write it how you want. Okay?
Oh, so you could write either one.
Yeah, I could have wrote f of x plus k as long as we knew we're talking about this one for the second one, not the one we started with. Does that make sense? Yes. Because we're applying each one at a time. We're not just reapplying it to the first function. Any other questions on this here? Now, we only have to do more than one if it tells us to do more than one. If it had just say translate right 4 and stop there, all we had to do was move it right 4. Yep, since it said right 4 and up 3, we went right 4 first, then up 3. In order, yes. Now, luckily for us, up, down, left, right, the order that we do it doesn't make a difference. It won't impact it. But especially if, I think they'll do this in college algebra, the order that you do vertical stretch and shrink and up and down will change the numbers, how they look. And the order in which you do horizontal stretch and shrink and move left and right, the order in which you do those will change it too. But otherwise, up, down, left, and right won't make a difference. Let's look at 32 through whatever we're at, because I know that the numbers changed a little bit. I added a few in. So, questions on 32 and 33, these two here. Questions on either one of these here? You can plug it in the calculator, yes. So for A, we can define, or for 32, we could define this as A and do 1/4 times A in the calculator and hit enter, and it'll give us the answer. Mm-hmm. Yes. Alpha y equals enter. So that's the most asked question is fractions, how to get those. Now the first thing we can do is for the matrix, we can go over to edit. Now for this one here, we have a 2 by 2. Go on and read it off because it's going to take 16, 24. Well, would it help? Go to 2. Quit. Okay, second matrix. Edit 2 by clear 2. There we go. 24. Okay, that makes more sense. 24, 16, 24, 39. Okay, we have this typed in, yes? We go second quit. Now for this here, we can say alpha y equals enter. That's how we get a fraction.
Come on, wait.
Alpha,
Let's do it on the
alpha, yeah, 1/4. Now we can call it the matrix, second matrix, enter, enter. And we get this here. Now, one thing I will say, with this, if you give one of the answers, if it comes out as a fraction, like with these here, put them all in fractions. Okay? Right, don't give me 4, 6, 15 halves, and then 2.25. If you put one as a fraction, put them all as a fraction. If you put one as a decimal, put them all as a decimal. That come out as decimals.
Isn't there a way like to pick up the other decimal?
Yes, math. And the first one, FRAC, hit enter, enter, and it'll change it. So we could do that there, or we could have multiplied every one of these by 1/4 and got the same thing. Yeah, we can say 1/4 times 16, which is 4. 1/4 times 24 is 6. Then we get 7.5 and 2.25, or the fractional form of these. Sometimes that could be faster, or if you don't feel as comfortable with that, plug it in. Because, I mean, with 31, you could plug that in and it'll do it all at once. We can plug it in as A, B, and C. It'd take a little bit longer. I would say 32 would take longer, or the longest, because we can say 2 times A minus 4 times B plus C, and plug that in. And for us to be able to add or subtract any two matrices or more, the dimensions have to be the same. They have to be the exact same, which means our solution will be the same dimensions. So for 32, since all three of them are 3 by 1s, the solution should also be a 3 by 1. Don't give me a 2 by 2. The dimensions aren't the same, right? So this would be no solution, or I think the other one was Now the systems for problems like that, I don't include no solutions on the test. Because again, with solving the systems of equations, a problem like that, there's a lot of work that goes into it. And most likely when you hit a problem like that and it comes up to zeros at the bottom or something like that, your first thought is normally not, oh, it's a no solution and that's the correct answer. It more likely will fall first into I did something wrong, then you'll spend way too long trying to see if you did something wrong, and then it ends up being no solution. Anyway, so I don't do those. However, it is possible for one of these on the addition subtraction to show up undefined or no solution. The reason I do think that I don't mind putting these in is because really we look at this here. Are the dimensions the same? No. It's either going to be yes, they are, or no, they're not. I don't think that is too much of a process. We're just really looking at it and seeing are they the same or are they not. If it's something like that, then I will include this kind of quote-unquote no solution. Because, okay, this isn't taking a lot of time or effort for y'all to figure it out or kind of look at it. You can see this pretty quickly. Okay, this doesn't work. We can move on. Those I will put in, but stuff like when we start solving systems of equations, stuff like that, I will put them on the review as no solution or infinitely many, but I won't put those on the test.
So 32 times 40.
Plus C, yes. That's fine. Any other questions with the addition, subtraction, and scalars? We feel good with these here? 38, 39, or 40 on the review, yeah.
Finish your flashcard.
I mean, that's going to be less than that.
How about 30? Boy, if I know it, my leg is going to hit that.
What are you trying to do?
How about 40?
You can just throw it back over here, you're good.
Throw it.
I threw that
Yep.
out.
What's the slope for 40? So slope. What's the slope of this line? So rise over run. How much is it going up or down? Is it?
Going up.
It's going up 65, man. It's not going up.
Because it started out with a y value of 65 and it went to a y value of. So is there a slope? Well, there is a slope. It is just what?
Plus
Yeah.
60.
Yeah. So that would be the slope. Now we could see it with our y2 minus y1 over 2 minus y1 over x2 minus x1. Because our one point that we have is 65 and over 5. Now the other y value we have is, what's its x value? 0. 0 over 5, which is, now the way that we normally find the equation of a line, we could say y minus y1 equals m times, we could pick 65 and 5. So we could say y is 65 equals our slope 0 times x minus 5. And your favorite multiplication, ever since I think probably elementary when they started making you do times tables, or whatever that was always 0, wasn't it? Because 0 times anything is. So we have y minus 65 is equal to, add 65 to both sides. And that's the equation. On test, I am just asking for the equation. I'm not asking you to describe the slope. I'm just asking you to find the equation. Y equals mx plus b. We need it in that form. So with any of the others, you need to find the slope. Use y minus y1 equals m times x minus x1. Plug it in, get y by itself, and you are. So y minus y1 equal over x times x minus, or so the slope is y2 minus y1 over x2 minus x1. Give me one of the two y values. Minus, what is 90's corresponding x value? Minus, so this here is the only one that we really have where order matters. Because if we pick 90 first, its x value has to go first. Whichever y value we put first, its x value has to go first. Now, at this point here, we can type this in a calculator. And 50 is on top. Now, for the most part, if I was doing this, I normally wouldn't grab the graphing calculator to type this in. Yeah, the yellow calculator is over here. Typing something like this in, it is so much faster for me to type this in on the 30XS than it is on the graphing calculator. Yes. And on the ACT, you can use both. You can only just have one out at a time. You have to simplify it to 2. Now we need to plug this back in with point. So we need to pick one of the y values. 40 equals 2 times x minus 15. we can distribute the 2. 2 times x's minus, add 40 to both sides. And that's it. Questions on any of this here? We feel comfortable with this? Yeah, you can use that on the test. Any other questions on this here?